Now, next up, we have a speaker I'm very excited to introduce. He is the VP of Streaming Data at Capital One. He's been there for about 4 years. And right now, all of you are thinking, VP of Streaming Data. Number one, what does he do? Number two, how do I get that job? Right? That sounds pretty good. Yeah, it's an engineering leadership role, as you will see. He's gonna talk about what's going on at Capital One. Prior to that, just to give you another idea of who this guy is, he spent about 10 years in a startup of his own that focused on mobile and big data things. Now, if you're doing the math, that gets you back to about 2002. I myself am old enough to remember nobody was saying big data or mobile really in 2002. So this is a guy who probably has some capability of looking ahead a little bit. So he's probably someone you want to listen to, and I'm delighted to welcome to the stage Chris D'Agostino.
Good morning, everyone. Thanks, Tim, for that introduction. Chris D'Agostino, I'm the Vice President of Streaming Data at Capital One. I actually live here in San Francisco, so I'm really excited to be here and talk about what we're doing to help enable an event-based architecture and basically transform the business of banking within Capital One from what most people think of banking as historically like not real-time, batch-oriented, and somewhat antiquated systems. So I think you'll find what we're doing to be really exciting. So I want to talk to you today about 4 things: the motivation behind this event-based architecture that we've built out, where we are kind of in that process or in that journey, talk a bit about the streaming data platform that my teams are responsible for, as well as some of the data management tooling that we're doing around event processing and event governance. Resiliency, big issue for us, right? We are a federally regulated organization. Like all banks, we need to not lose data, so we need to make sure that the systems that we build out can scale and stay up. And then finally, on that topic, the software development kits that we've built to enable people to stream more easily, both producers and consumers. And then we'll talk about when you're working in an organization where we're in probably 5 or 6 different cities in the United States. We've got nearly 10,000 software engineers, 40,000 employees overall, roughly. We need to be able to scale out, and we need to be able to make it very easy for people to produce and consume data, whether it's stream data, APIs, or what have you. And then finally, as we move towards this sort of fully robust event-based architecture with thousands of events flowing through the system at any one time, or thousands of event types flowing through the system at any one time. What we want to be able to do is basically, as Jay was talking about, react to these business events in an if this, then that style. So we'll walk you through that. So for those of you that are Capital One customers, you may have been enrolled already for our digital assistant. You can think of it kind of like the Amazon Alexa for Capital One. It's basically a real-time, intelligent, and automated digital assistant that's basically looking at not only your transaction history, your spend habits, applying machine learning algorithms to determine what transactions and what types of behaviors make sense for you as an individual customer. But that capability is completely dependent on events streaming through Capital One. And so we've got 4 different lines of business. We've got, as you may know, obviously the credit card division. We've got a banking capability, commercial banking, and then we have an auto loan capability or line of business. We tie those together in terms of a unified customer experience through a digital organization. And then I'm part of what's called shared tech. So we're an enterprise service arm of the company that builds out enterprise platforms that are to be used across the entire company. So in order to do this, and make Eno what it is today and further improve it as we move forward, we need to be able to identify events that run the business, identify events that are meaningful to our customers, and instrument these source systems that are traditional sort of end-tiered applications, instrument these source systems to emit these events. And so everything from clickstream events in our mobile application, our web application, everything from our internal systems that generate business events when payments are posted against accounts, when money is moved between accounts, all those events get triggered and flow through this platform. So let me talk to you a little bit about the goals that we had when we set out to build this. So as I said, we're based out of Washington, D.C., or McLean, Virginia. We've got offices here in San Francisco, New York, Richmond, Virginia, Plano, Texas, Chicago. We're in Toronto. So you've got engineers spread across the entire company that represent the engineering efforts and systems that are being built for these discrete lines of business. So the first thing that we wanted to do was make sure that we had a consistent approach to how we built out a streaming platform, and that each team didn't go off and build their own style, whether it was Kafka or some other streaming environment. We settled on Kafka for all the reasons Jay has mentioned, but we wanted to make sure that we were being really consistent, rolling out upgrades in a uniform fashion, and making sure that we had a similar dev, QA, and prod environment, so that as you moved your streams through those different environments, that you got the same sets of results when you finally went into production. The second thing is producer autonomy. Each of these lines of business are responsible for their own P&L, and so what you don't want to have happen is some issue on the card streaming version of this card streaming platform, or that segment of our streaming data platform, affect other lines of business. And so we needed to determine how to set up a topology where we could have consistency in the way that the platform is rolled out, but also isolation and control of blast radius. Likewise, because of regulatory requirements, data sharing between lines of business is regulated strictly and needs customer consent. And so you've got an additional layer of data management capabilities that need to be put on top of this. And those tools are also built by teams in my organization. So we are tying all of this together as a sort of a governed platform. So the data governance piece of that, the third item here, is really making sure that producers have the accountability for the data. We want to make sure that we're not doing traditional things like you saw in data warehousing environments, where data would just go in, the data might be messy, you're running a bunch of ETL scripts to try and clean things up, maybe you're normalizing date timestamps and things like that. We wanted to make sure that we got out in front of that with this streaming environment and get all those records uniform, consistent in their formats, data quality checks applied before the event even makes it into the ecosystem. And then finally, with the idea of data flowing in real time, it generally, it flows through the streaming data platform, it gets aggregated up, it gets deposited into our OneLake environment. Some traditional analytics happen there where it might get loaded into things like Redshift or Snowflake. But that time between when the event fired and the time that it gets finally loaded into traditional data warehousing techniques is far too long for a business to operate the way that we want to operate. So we need to be able to react to these events in real time. We need to be able to do things like joins and aggregations and filters on events. And so we'll talk more about that as we move forward. In order to get people streaming, obviously when you build an enterprise solution, for those of you that are in that kind of part of an organization, you need to really worry about adoption. You need to make sure that you make the platforms as simple and easy to use. You do a lot around communication, a lot around building out capabilities to ease the burden of onboarding onto these platforms. And so what we have done at Capital One is we've created a single exchange inside the company that developers can go to either produce APIs, produce streams, discover APIs and streams that they might want to leverage in their applications, and I'll walk you through what that feels like as a user to define a stream in real time. So for a topology, as I said, we're running credit card transactions, we're running money movement, payments, things like that flow through this environment, so the system cannot go down. And so what you're seeing here is what is a standard sort of blueprint for when we build out a cluster. So I want you to think about our environment as 2/3 physical and 1/3 logical. So the 2/3 physical is we're building out discrete clusters that represent and provide capability for streaming for different lines of business. And one line of business might have multiple clusters, for example, depending on the number of streams and the amount of data that flows through. But what we need to be able to do is then also ensure that none of those go down. And so the topology that we've landed on that we feel really good about is we'll build a cluster. A single cluster on your left in one region will be split across multiple availability zones. And then we will replicate using Kafka Connect the data to a an identical cluster set up in an opposing region. And we are a multi-region, multi-cloud company, so this is one example with one cloud vendor we've got similar topology for other cloud vendors as well. But what happens is, when you go through the workflow, which I'll show you here in a bit, and you define a stream, because of the resiliency requirements, we will automatically provision that stream in region 1. We'll configure that stream in region 2. We'll configure the replica of the streams, and then with our SDK, as a producer or a consumer, it really doesn't matter which broker you're talking to and which partition you're writing to, because we keep track of all that and we dynamically switch between them. So, Capital One's known really well in industry with its focus on customers and the user experience around how we treat our customers, not only in terms of our banking policies, but also with our mobile app in particular. It's been an award-winning app for years, and continues to be at the top of the fleet with J.D. Powers. So we need to be able to bring that same type of design, that same type of empathy research to our internal users and make sure that when they're trying to do their jobs, they have as good of an experience as our actual customers do. So, but you've got to be able to govern it, and as an engineer myself, like, nobody wants to be told this is how you have to build software and this is how you have to define an event, but if you're going to do that at scale, you've actually got to apply some governance around it, but make it as simple as possible. And we haven't completely eliminated the human being from the review process. I'll give you some metrics as to where we are now. We've been at this for about 1.5 years now for the overall platform, but when you go into the planning stage and you define the stream, we've got some very strict guidance that says only the system of record that is the authoritative source for a piece of information is able to stream that data as the author. If you restream that data, maybe you create a composite stream or something, you will have to, the SDK will automatically give attribution to the parent stream. And this is part of the data management tools that we're working on. I won't go into too much detail there, but it's part of the lineage requirement of being able to trace back, no matter where a piece of data is being used in the organization, be able to trace that data back to the system of record that it came from. So the design, we go through a user experience where you go through, you describe what your stream would look like in a JSON format. We have a naming convention. We validate that the names for the streams are available and not being used already. We have data quality rules. So as I mentioned, we want to make sure that the events that go into the ecosystem are healthy events. So we will run data quality checks against those. We'll watermark the data since they're immutable records. If you then leverage that data later, you can check that watermark with a very quick calculation, and if that matches, you know that the data is what was intended to go into the system, and you can rely on it. We go through a design review for the stream, just making sure that we are taking care of NPI and PCI data, and we're tokenizing it, we're encrypting it so that the data is secure for our customers, and then we deploy the streams into the dev, the QA, and the prod environments. So here's what it looks like if you're going through the planning. This is like, I'll build up the screens here, but you basically go through, you define the stream name, you define the engineering teams responsible for creating the stream, so we have attribution back to who we need to talk to in order to get streams adjusted if need be, or the consumers can go in and look at the stream catalog and figure out, like, hey, this stream doesn't contain a field that I think it needs to contain, and you can work with them. We have the capability to version streams, have multiple versions running at the same time in production, sunsetting the prior versions over time. You do the stream definition in a JSON editor, and what you can't really see down here is the ability to start applying some rules, but within the user experience, we basically walk through and you can check for values to make sure that they're not null. You can do regular expressions. You can look for specific ranges of values that the data needs to satisfy. Then we provision the stream into both the dev and the IT environment, and IT is our internal word for QA. And what happens then is we basically create a configuration file and we give you an SDK, either in Python or Scala. There is a Spark library that we use since we're a big Spark shop as well. And what we do is that configuration basically sets up all that capability for being able to talk to brokers in multiple regions and be able to partition, send topic data to the right partition. And then once you go through the design review, and you've been at this point in time as an engineering team, you've been testing your code in both the dev and the QA environments, and in the background, the design review team for the stream definition has reviewed your stream and made some adjustments with you potentially. But once you do that, you're now in production, and then you just sort of rerun that loop for new streams, or if you want to iterate on the existing stream. So we came up with a standards document and basically described an ontology. So what we wanted to do is we wanted to make sure that events were consistent in terms of their semantic meaning. So if you think about the CRUD operations for things that might happen in an organization, you could create something and use that semantic meaning. You could call it new. We wanted to make sure that we created a finite enumeration of values so that when you went through, it became pretty easy for you to describe what that stream was designed to do. And then you can see down at the bottom, we're checking the availability of that stream definition. And so if you were to go to our stream catalog, just reading it as an end user, the streams intuitively make sense. So let's talk a little bit about the SDK features. I touched on these a bit, but we are using X509 certificates to authenticate people from systems from a producer to the SDP platform or for a consumer. And so all that dynamic, certificate generation, all of that stuff takes place inside of our SDK. The SDKs just basically wrap the native Kafka SDKs, but we do additional things like the data validation rules, we check the schema, we have the secondary support for producers, secondary cluster support for producers. So if you are a producer, you don't really need to worry about whether or not you're talking to a cluster that's in the East region or in the West region, or if the East region goes down for some reason, it dynamically switches over. We keep track of the offsets for the producers and consumers themselves, or for the consumers rather. So how are we doing in terms of rolling this out and getting adoption? So we have 1,500 streams that have gone through this process. We are continuously evolving the user experience and the workflow associated with defining streams. We're trying to get machines to be more involved in validating the schemas and things like that and take the human out of the loop. But for now, since, again, we are a regulated organization, we want to make sure that we're really cautious. But we have over 27 billion events that have flowed through the environment to date. And that doesn't even include some large swaths around our cyber capabilities that once that data starts flowing through, these numbers will skyrocket. So stream design, 75% of the streams are designed within 3 days. And you need to think about, those of us that are here at this conference are either used to streaming and have a really good sense of how you might instrument a producer application or how you might instrument a consumer app to read and react to these streams. For us, it's been a bit of a journey to teach people and to go out to the sites. We have road shows where we go to each of our locations and we work with the engineering teams. We have tutorials that we've set up. So within Capital One, we want to make sure people are streaming in a particular way, and we want to make sure that they're following all the governance processes that they need to. The stream review, so it takes about 2 days. I know we tend to be an impatient bunch in terms of the engineering community, but 2 days to get a stream reviewed and approved so that you can actually start emitting events that people can consume and react to is not too bad. And then it takes us less than 2 weeks to get streams out to the production environment at this point. So we're always looking to improve that. So here's an example. This is a project that I worked on when it was a batch-oriented project. This goes back a few years. And for those of you that are Capital One customers, you'll know what second look is. It's basically it's, as it sounds, it's a second look. So a transaction that you've performed with your credit card or with your ATM debit card, that transaction, once it's approved, it's not viewed as fraud, but we're not quite sure whether or not that transaction is something that would be, that you'd be concerned about. So for example, if you went to a restaurant and the bill was $100, and we know based on your spending habits in the past, you typically tip around 20%, let's say the tip comes in at 40%. The second look algorithms will pick that up and notify you. But in the past, it was done via a batch process. So we would run these things nightly. Customers love it. You see the 90% score when we do the surveys down there in real time, or not in real time, in the feedback surveys from the emails. But the emails, we were sending out a lot of emails because a lot of these algorithms were triggering. So double swipe algorithms, so if you went to a merchant and they swiped your card twice, most people, myself in particular, I'd never notice that. I don't go back and look at my statement and try and see if Starbucks or somebody charged me twice for a cup of coffee. But what we can do now with the platform is in very simple orchestration with emitting events, we make 3 RESTful API calls. The algorithms trigger and give a result, and then we can alert the customer in real time. So if they were charged twice in a particular store, and in this example, it's like a bicycle shop or something, if they were charged twice, all they would need to do is just go back to the cash register because the alert came in probably before they even left the store. So, and this is all running through the streaming data platform. So where are we headed? We look at events, as Jay described, as basically running our business. And when you talk to business people within our organization, they talk about wanting to be able to react to events if certain events take place, and oftentimes it's a combination of events. So a very common fraud case in financial services is if somebody calls in to a call center and updates their home address or a shipping address. And then someone goes through the self-service app and requests a new card, say that their card was lost or stolen. So now somebody has done an account takeover. These in most banks, including us, these are discrete systems that don't talk to each other necessarily in real time previously, but now they do. And so when those events take place, our fraud algorithms are looking for a sequence of events that take place. But even today, we are still in the position where both producers and consumers need to read those events in and need to be able to react to them in their own code base. And so that requires software engineers to go in and change the code, change the rule sets. Do they do it consistently from one project to another? Not sure. From one line of business to another? Definitely not sure. But what if you provided a layer on top of the event platform that allowed them to define an IFTY-style rule? And because we have the schemas and because we have the event ontology, we're able to have people be able to basically say, yeah, these 3 events and these attributes within the events, we want to be able to just describe a rule based on that and trigger a RESTful endpoint or trigger a notification to a customer if the constraints were met. So, in order to get us there, one of the things that we're doing is creating this concept of a lens. And so the lens is being able to go through and describe how you might join up different events, what attributes you care about within those events, and then we are really excited about KSQL as a capability of being able to basically write a select statement, if you will, against that and create one of these virtual tables that the events would sit in and make those results available sometimes as another stream, oftentimes as another stream, but sometimes as an API. So if you think about windowing and you might want to look at, say, a customer's session data on the mobile application, they spend about 7 to 12 minutes per session at most when they're going through and looking at transactions. That's sort of the long end of it. And what if we wanted to be able to trap those events, look at that session data and look for things where they might have gotten stuck? Perhaps they tried to make a payment or move money between 2 accounts and then they abandon it. We wanted to be able to not have to wait for that data to go into the analytics store where we would process that, because by that time, the customer is off the application and not using it. Or if they call into our customer call center, we want to be able to say, hey, this is exactly what you were doing when you called in, and so maybe we can really short circuit the support path for you. So we want to be able to create these tables of events, have windowing against them. We want to either emit those as a new stream, sometimes it's filtered, or we want to be able to have that fronted by an API, a coarse-grained API. But this also allows us to create filters. Say, in our authorization request stream, we've got 3 different credit cards. You've got your Quicksilver, Saver, and your Venture cards. If we were really only interested in Saver transactions that were greater than $300 for a set of accounts within a particular zip code and a radius around that, we can do that with this type of platform processing. And so here's an example of what we're doing. We call it sort of taking the fire hose and creating the garden hose. So we've described a rule that says we want to be able to look at transactions for accounts that are of type XYZ and whose dollar amount is greater than or equal to some threshold. And so you'll see we selected the 3 out of the 4 transactions that matched XYZ there, and then we create that and we're able to react to those events. So again, being able to do this in almost real time as opposed to waiting for the data to go into the lake environment and pull that data from there. For those of you that know what IFTY is, you see it a lot in home automation. So when you arrive at your house, the garage door might open, the security alarm disables, the lights turn on. We want to be able to do something similar to this inside of Capital One. This is not a platform that is commercially available, so what we're doing is we're in the process of building teams in San Francisco, DC, New York, that are going to help us be able to build out this type of platform. And here's a quick look at the architecture. So this IFTTT rule engine is really the heart of the engineering effort that we're working on, but everything that's going to feed into this environment comes through this streaming data platform and is backed by Kafka. And that's all I've got.